Today we want to start our review for our final exam. And today we want to look at probabilities. And specifically we want to look at binomial and normal probabilities. So we want to kind of go through and refresh our memory on what's the difference between these two kind of major types that we have dealt with this year in terms of probabilities. So if you remember, binomial is a discrete probability, which means you can get 0, 1, 2, 3. You know, binomial is how many times you hit a target, whether something is true or false. Normal distribution is continuous. You get decimals. You measure what's the weight of something, what's the length of something, what's the temperature of something. Those types of things are normal. With discrete, you have two outcomes: pass, fail, true, false, hit, miss, those types of things. When you have a normal, you end up with your mean, your standard deviation. You can have a continuous number of possible data points. You can't have a mean and a standard deviation necessarily as easily for binomial. You're dealing with p, you're dealing with percentages, you're dealing with proportions. Those are the things you're dealing with binomial. If you're dealing with the mean, if you're dealing with standard deviation, now you're dealing with normal. Both types have n, which is the number of sample space. Binomial, many of you on your final project, when you ask a question, yes, no kind of question on your final project, you were dealing with binomial distribution. You did a survey and you got two possible answers. Now, can you find the mean or the average in binomial? Can you find the standard deviation of a binomial? Yes, but when you're dealing with binomial problems, usually you're not given those kind of pieces of information like you are in normal. To do these on the calculator, we have binomial PDF is NPR, and normal CDF is our upper, lower, mu, and sigma. Now let me say right off the bat here, I'm going to do everything in this video using the calculator, and I'm going to do a separate video for those of you that do not have a TI-83, just explaining how to do everything you need to know for the final exam using the GeoGebra online program. Now, we also could get a sampling distribution, which is when we need to divide our our standard deviation by the square root of n. So, and we'll talk about examples where we need to do both of those. Now, as we go forward, binomial distribution is what we use when we do a p-interval or a p-test, when you think of doing those on your calculator. Normal distribution is what we use for a z and a t, whether we do a z or a t confidence interval or a z or a t hypothesis test. Now, there's other kind of probabilities besides these two. These are the two that are kind of built into our calculator. These are the two main ones we've looked at all year. But there's other kind of probability questions you could also come across. If you get things about cards, if you get things about lotteries, if you get things about surveys and charts that they give you the information in a table, if they give you other information, you know, how many marbles in a bag and what chance or probability of pulling out a certain color. Questions using the formula, what's the probability of A or B, or what's the probability of B and A and B, or B and A or B. All those kind of things. These are all other kind of probability questions, but they don't involve binomial and normal. So let's look at some examples. A traffic control engineer reports that 32% of vehicles passing through a checkpoint are from outside the home state. What is the probability that exactly 5 of the next 9 vehicles are from the home state? So you can see right away, you have to ask, what are the possibilities? Nothing talks about means or standard deviations or anything, so you know it's not normal. So you have to decide, is it binomial or one of the other ones? Well, they give you a p, 32%. They give you an n, number of trials, 9. And they give you a number of successes, an x, which is 5. So if you take all of those and you put them into your binomial PDF, 9, 32, you can't see it here, 5, you can get your 0.09. Look at another one. For the Illinois Lottery Pick 3, a player must match a sequence of 3 repeatable numbers from 0 to 9 in exact order. With a single ticket, what's the probability of matching the 3 winning numbers? Notice, this is not mean, standard deviation, so it's not normal. They don't really give us a probability and a number of trials. It's not binomial. This is just the probability where you have to figure out what's the probability of winning. If you have 3 numbers from 0 to 9, how many possible numbers are there? So you do the fundamental counting principle. How many ways can you pick the first number? 10. The second number, 10. The third number, 10. So if that's how many different numbers are possible, what's your probability of winning? 1 out of 1,000. So number 3. The reading speed of 2nd grade students is approximately normal, with a mean of 90 words per minute and a standard deviation of 10 words per minute. What is the probability that a randomly selected student will read more than 95 words per minute? As soon as you see this kind of probability and it gives you mean, standard deviation, you know you have normal CDF. Now, you can't see it here. I'm going to do it here in a second. If we look at the same problem over here, if we do this on normal CDF, you remember if it's more than 95, you do 95, and then your upper is just 9999999, and then 90 and 10, and you get your probability. Now let's say we change this to this. What's the probability that a randomly selected sample of 12 will read more, or average more is what it means. Average more than 95 words per minute. Almost exactly the same as the previous one, but you're talking about the average of a sample. And that is when we have to divide by the square root of n. So that's the difference between these. When you're dealing with this normal CDF, if it is a singly randomly selected student, it's just your sigma. If it's a sample and it's the average of that sample, you have to divide by the square root of n. And it makes sense in this case that that number is going to drop, because if you're looking at the average of a group of students, you wouldn't expect the average to be as high as just randomly selecting one student. And the last one, suppose 3 guards are drawn without replacement from a standard deck. What's the probability that all 3 are aces? No mean or standard deviation, not normal. No percentage, number of trials, not binomial. This is just a probability question. So what's the probability of getting 3 aces? It's 4 out of 52 for the first ace. There's no replacement, so it's conditional. It changes the probability of the second one. It's only 3 out of 51. The third one is 2 out of 50, and that gives us our probability. So you are now ready to do the homework over the probability. This is the day 1 of the review for the final exam. And as I said, if you are not using the TID3 and you're trying to do it using the computer, I will post a video that goes over all of the things I've done here and more, and reminding you how to do them on the computer.